Hey guys, so today we're going to discuss the question called as reorganize string. So this is a Leetcode medium question. This is also a very important question because this question uses an important data structure called, I'll tell you that later. So let's start with the question. So given a string S, rearrange the characters of S so that any two adjacent characters are not the same. Return any possible rearrangement of S or return an empty string if not possible. So what they're trying to say is they'll be giving you a string, let's name it as S, right? So they'll be giving you a string and you have to rearrange the characters in that string so that no two adjacent characters are not same. If at all they are same, they shouldn't be side by side. That's what they are trying to say. So you have to rearrange them such a way and return that rearrangement string as an answer. If it is not possible, if the rearrangement is not possible, then you have to return an empty string. That's it. That's the requirement here. So let's try to take an input. So let's try to take given example one only. Let's try to take an input which looks like this. This output contains characters A and B. So it has two A's and one B, right? So you have to rearrange these characters so that no two adjacent characters are same. So in this case, if you see clearly, these two characters are same and they are side by side. So that's the requirement. I mean, that's not the requirement. They shouldn't be side by side. They have to be in such a way that no two adjacent characters are not same. So let's try to find out how can we rearrange this. So for example, here we have two A's, right? So let's take that frequency as well. A has two, there are two A's, there is only one B, right? So this is our frequency of the characters. So now let's try to rearrange them so that we match the requirement. So first of all, maybe let's take 1B. I'll take 1B and I'll place one of the A. And so for now, no two are same, right? No two adjacent characters are same. So we are left with one A. So if I place A here, so to that two A's which are same, so they are side by side. So this is not the right rearrangement. So I'll be taking one A and another A and one B. So this is also two A's are side by side. This is not the right arrangement. So let's take an A and I'll take B because B is not A and B are not same. And now I'll take the leftover A, which is A. So now no two adjacent characters are same, right? Because A is not equal to B and this B is not equal to A. So no two adjacent characters are same. So this is the answer for this input. So this would be the output. So this is the answer for this given input. So now based on what we can verify or we can know which letter to place, right? So for example, we have seen many possible combinations, right? Before we have tried BAAA, but this is not satisfying the given requirement. So but at last we have got ABA. So based on what we have to decide which character to place. So let's take an example, let's take another example, and let's try to find out based on what we have to do that. So now let's try to take an example. Let's try to take another example which looks something like this. So here we are having three A's. So we are having three A's, one L and one O. So right, let's try to take the frequency of those characters. So as we have seen, A is repeated 3 times, L is repeated 1 time, and O is repeated 1 time. So these are the frequencies of our characters. So right, so let's try to rearrange them. So let's try to take the characters which has less frequency. Let's see what happens. So for example, here the frequencies are 3 1 1, right? So L and O has one frequency which is less when compared to A, right? Let's take L initially. So L, I have done with 1 L, then it would be 0 now. So let's take the other less frequency one, which is O, right? Which is O. So we are done with this O. So now the leftover character is A, right? So we'll put 1A. So now we'll have only 2 A's. So the only character left is A as well, A only, right? So we have no other option, we have to put A only. So now if you see, there are 2 A's side by side because we have no other option, because the only character which is left, characters which are left are A, right? So what's happening is, if you try to take the characters which has least frequency at the beginning, then at the end you will be having no other option, because you have to take the characters which has more frequency at the end. So if there are many characters of higher frequencies left over, then they'll definitely be side by side for sure. So in this case, what you can do is, based on this example, you have to take the characters which has high frequency first. That's the intent. You have, if you take the characters which has high frequency at the beginning, then you can just you can map with some other high frequency character and just put side by side. For example, let's take another example. So let's take this example. Let's take another example which looks like this, where it contains A, B, B, and C. So the frequencies are written here. A is repeated 2 times, B is repeated 2 times, and C is repeated 1 time. So as we have discussed before, we have to take the characters which has high frequencies, right? So the best data structure for that, for getting the the character which has high frequency, would be a heap, right? A heap is something which is implemented either a min heap or a max heap. So in this case, as we want the maximum frequency one, right? So the max heap is the best one, which provides us the one which has high frequency. So what I'm going to do is, maybe I would take something like a data structure. Let's take maybe which looks like this. So I'll take this kind of a data structure, maybe like a class which is named after a pair or a node something. So in this case I've used pair. So it contains 2 variables, where one variable will be a character and another variable will be a frequency of the particular character. So I can use it as a node, right? So what I can do is, I can store the frequencies of the characters, and I can just store these nodes in a priority queue, in a max heap. So that priority queue or max heap is going to rearrange these elements, so that the maximum character or the maximum frequency character will be at the top. So now let's try to take that. So as A has frequency 2 and B has frequency 2 and C has frequency 1, right? So obviously either A or B will be at the top, right? So if at all we insert A first, then A will be at the top. If at all we insert B first, B will be at the top, right? So now let's try to take a queue. Queue is nothing but a priority queue, which is also called as a heap. A priority queue, right? So let's take a queue. So initially A has more frequency, right? A will be at the beginning. So next B will be at the beginning, and the last C will be at the beginning, right? So now what I'm going to do is, I'm going to take the one which has more frequency, as I said before. So I'm going to take 2 characters which has more frequencies. So initially A is there, right? I'll be taking A out. I'll be taking A outside the queue, and I'll be taking B outside the queue. So A has frequency of 2 currently, B has frequency of 2 currently. So I'll take one of it, one A and one B. So because these are not same characters, so I'm going to place side by side. So now the leftover one is 1A and 1B, right? So it's going to be 1A and 1B. So as there are A and B left over, I'm going to add A back and B back. So now C will be the next one, right? Because C has frequency of 1, A has frequency of 1, and B has frequency of 1. So now let's take another 2 characters which has highest frequency. So in this case, C and A. Let's take C and A. I'll be taking C outside the queue and A outside the queue. So now I have A, C, and I have A. So I'm going to place C here and A here. So C frequency will be going to 0 and A frequency will be going to 0. So we cannot insert the C and A back to the queue, because they are done. I mean, there are no C and A left over, right? So C and A are over. So the only thing which is left over is B. So what I can do is, I don't have to insert the C and A back to the queue again. So the only thing left over is B, right? So I can take this B outside the queue and just put at the end. So now we have got a string. We have got an arrangement. So if you see clearly, no 2 adjacent characters are same, right? See, so A is not equal to B, B is not equal to C, C is not equal to A, and A is not equal to B, right? So what if there is a single character which has more frequency than 1? For example, let's say we have B left over and B has frequency 1 currently, so we can just put at the end of the current string. What if B is 2? For example, let's imagine B has frequency 2 currently, and there is only one character which is B. So in that case, we have no other option, right? Which we have to put 2 P's side by side. So in that case, if at all there is only one character at the end, one character in the queue, if maybe like queue size is maybe let's take greater than 1, right? I mean equal to 1 at the end, and that frequency is greater than 1 as well, then we can just return an empty string because we don't have any other option. It wouldn't be possible to create the requirement. Then if this case is, if this condition satisfies, then we just have to return an empty string. That's it. If there is only one character left, then it would be easy for us. We can just put this character at the end of the answer string. That's it. So this is the approach. This is how we use a priority queue, and we get the maximum frequency character, and just we append to the answer string to like one by one. That's it. If at all we have the leftover the character, we just put in the queue again back and do the same process again. So let's try to take let's try to implement this. Let's try to take the test case, and let's try to implement this using code. So now we are having a method called as reorganize string, where the input parameter is of type string. So we have to rearrange the characters in this string so that no two adjacent characters are same. That's the requirement, right? So now what we have done before, by taking an example, we have tried to find the frequencies of the characters, right? So what I'm going to do is I'm going to use a hash map to show the frequency of the character. So it's going to be a hash map, right? So where the key will be of type character and value will be of type integer. So hash map. So I'm going to iterate to the given string. So s dot to char array, where map dot put c, and the value is going to be map dot get or default c comma 0 plus 1. So now, as we have used the queue, right? A queue is nothing but a priority queue. I mean, so a priority queue is nothing but a heap. So in our case, we need a max heap to get the maximum frequency character. So I'm going to use a priority queue. I'll tell you what type I'm going to use, and it's going to be a queue, a new priority queue. So now, initially, like by default, a priority queue in Java is nothing but a min heap, but our requirement is a max heap. So for that, we have to write a custom comparator for that. So what I'm going to do is I'm going to take a data structure which is called as node maybe. So as I said before, I'll be taking a data structure or a class where it contains two variables. One is char c and char int f. C is nothing but the character, and f is nothing but its frequency. So maybe I'll add a constructor as well. So char c int f, this dot c is equal to c, this dot f is going to be f. So I'm going to filter this based on the frequencies, right? I'm going to use a lambda expression for that. So it's going to be b dot f minus a dot f. So now, as you are storing a character along with its frequencies of type node, right? So it's going to be of type node. So now I'm going to take the frequencies along with the characters along with these frequencies from the map. I've stored them in a map, right? So I'm going to iterate to the map dot entry character integer m map dot entry set. So now the character is going to be char c is going to be m dot get key, and int frequency is going to be m dot get value. So I'm going to add this to the queue dot add in the form of a node, new node of c and f. This is going to add to the queue. So after adding to the queue, what I'm going to do is maybe I'll take an answer string. So let's name it as string builder. So string builder is something which is used to manipulate with the string. It's a class. It makes things faster instead of using a normal string. So I'm going to use string builder, new string builder, right? So now what we have done before, we have tried to take two characters which has highest frequency and try to add them side by side, right? So for that, we have to make sure the queue size is at least 2, which actually means while queue size is greater than 1, that actually means at least greater than 1. What I'm going to do is I'm going to take two characters. So it's queue has of type node, right? So it's going to be, let's take like first queue dot poll is going to take the first one, and the second one is going to be second queue dot poll. I'm going to take the second one. So now I have to place these two characters side by side. So let me fetch the character from this node data structure. So let's name it as fc. So first dot c char sc is going to be second dot c. So now what I'm going to do is I'm going to add these characters to the answer. So answer dot append the fc character, answer dot append the second sc character. So now I have to decrement the frequencies of these, right? So the frequency will be in this node variable, so which is of type f, right? So what I'm going to do is first dot f minus minus, second dot f minus minus, decrementing by 1. So now we have to add these characters to the queue again if at all they are left over. So for that I have to see if first dot f is greater than 0, then q dot add the first back to the queue. If second dot f is greater than 0, then add the second to the queue again. So this is what the actual process, repeating process again and again. So this is going to create an answer string, and as we have seen before, there might be one character which is left over at the end, right? So for that, what I'm going to do is I'm going to check at the end. So if q dot size is greater than 0, then I'm going to take the character, let's say current character. So it's going to be q dot poll. So now I have to see if current dot f is greater than 1. So if there are two characters, if there is only one character and its frequency is greater than 1, then actually means they would be definitely side by side, right? We have to definitely place them side by side. So then that actually means it's not possible to match the given requirement. So then we have to just return an empty string, or else what I have to do is just answer dot append current dot c. That's it, because we only have one. So at the end, what I'm going to do is I'm just going to return answer dot to string, converting the string builder to a string. So this is pretty much the implementation of it. Let's try to run this. Let's try to make sure we don't have any mistakes. Yeah, it worked. Let's use some extra example test case as well. Okay, reduce wait time. Okay. So let's see. Yeah, it worked. Let's try to submit this. Yeah, it got succeeded. So yeah, this is how you use your Max-Heap and try to find out the rearrangement of the given string. So this is like as you have seen the intention for that, we have to make sure we get the maximum frequency characters at the beginning. So for that, so instead of prior to queue, we can also you try to use a list with these node types and try to sort that list based on the frequencies. So that in that case, we have to sort each and every iteration. For each and every iteration in this while loop, we have to sort that list. So instead of doing that every time, what you can do is you can maybe use a Max-Heap like we have used now, and that's going to automatically provide as the one which has maximum frequency. So that's the case I have used this priority queue. So if you like the video, please make sure you like and subscribe. Thank you.